Hi, let's take a look at some problems from section 2.3 homework. The first type of problems that you're going to need to be able to do is to write an equation that results in the desired transformation. So when changes are described to you, you should be able to produce a function that expresses those changes. So let's take a look at a couple of these. Like for instance, number 4 says to do the cube root function reflected across the x-axis. The cube root function reflected across the x-axis. So our basic function is the cube root. So if we think about f of x is the cube root of x, what is the transformation? It is reflected across the x. Well, to reflect across the x-axis, remember what happens. The y values are opposite, right? So we're changing the y values whenever we reflect across the x. So that would be an outside change. So the desired transformation would be that y is equal to the opposite of f of x, if you want to say that, or the opposite of the cube root of x. Now, number 6 says to do the absolute value function, so our basic function is absolute value of x, vertically shrunk by a factor of 1/3. So vertically shrinking is the outside change, that is, we're multiplying the y values by 1/3 and reflecting across the y. Well, to reflect across the y-axis, the x values are opposite. So to reflect across the y, we're going to have to take the opposite of x. So what we're really trying to find here is 1/3 f of negative x, which in this case would be 1/3 times the absolute value of negative x. But actually the absolute value of negative x is the same thing as the absolute value of x, so either one of those would be acceptable. The next type of problems is just to fill in the blank with the appropriate response. It says to remember that the vertical stretch or shrink factor is positive. So for instance, number 26 says to describe the changes here. The graph of y is equal to -2/5 times the absolute value of negative x plus 6. Really looks like the problem that we just worked. It says can be obtained from the graph of absolute value of x by reflecting across the, well, notice there's two negatives here. There's an inside negative and an outside negative. The outside negative reflects across the x-axis and the inside reflects across the y. But we always want to do reflecting across the x-axis first, then vertically shrinking by a factor of 2/5, reflecting across the y-axis, and now shifting vertically by 6 units in the positive direction or upward direction. I'm just doing a sampling of these. If you need more, please contact me and we can go through more individually. These are important problems to do to be able to use transformations of graphs to sketch a graph by hand. Now certainly you could plug into the calculator and you could get the graph pretty easily, but I think it's important to be able to do some of these by hand. So let's take a look at number 44. It says to graph f of x is equal to the square root of negative x minus 1. Well, our basic function is the square root of x. So again, key is knowing the basic functions really well. Now the negative x, what happens there? If we take the opposite of x, that is doing a reflection across, do you remember which axis? Yeah, opposite of x is reflection across the y-axis and then shifting down 1. So we need to reflect across the y and down 1. So what will happen? When we reflect across the y, we are going to do the opposite of x. And when we shift down 1, we're going to subtract 1 from the y. Well, what am I talking about doing that to? That is the original points on that basic function of the square root of x. So let's review the square root of x. Square root of x is at 0, 0, 1, 1, and 4, 2. There's other points on the graph, but those are some of the key points that you should be able to identify. Now, so we take these through the transformation to reflect across the y-axis. That 0, 0 is going to stay 0, 0, right? When we take the opposite of x, it doesn't change, but when we shift it down 1, it's going to go down to 0, negative 1. What about 1, 1? Its reflected value through the y-axis is at negative 1, 1, but when we shift it down, it becomes at negative 1, 0. 4, 2 reflected would become negative 4, 2, but then shift it down 1 would become negative 4, 1. And so this is our graph of that transformation. Now you can certainly plug into the calculator and just confirm all of that to be true. Okay. A lot of these are involving the square root of x. I was going to try to do one more. Let's see. Let's talk about number 38, for instance. 38 is 1/2 times x plus 2 squared. So 1/2 is a vertical shrink. That is, it's going to multiply the y values by 1/2, and the x plus 2 is going to do what? Yeah, it's going to shift left 2 units. So our basic function that we're talking about shifting is the x squared. So on x squared we have 0, 0, 1, 1, 2, 4, and negative 1, 1, and negative 2, 4. Oops, sorry about that. Okay, let me identify these points. Okay, so now if we're going to shift these in this manner, we've got to move x left by 2 and then multiply the y values by 1/2. So if we move 0, 0 left by 2, that's going to take us to negative 2, 0. When we multiply 0 by 1/2, we stay at 0, 0. 1, 1 shifted left by 2 takes me to negative 1, 1, but if I multiply the y value by 1/2, I actually get negative 1, 1/2. 2, 4 left by 2 takes me to 0, 4, but I've got to multiply the y value by 2, by 1/2, and that would take me to 0, 2. Negative 1, 1 shifted left by 2 takes me to negative 3, 1, but multiply the y value by 1/2 would be negative 3, 1/2. And then one more, negative 2, 4 left by 2 takes me to negative 4, 4, but multiplying the y value by 2 takes me to negative 4, 2. And so my new graph would look like this. Okay. Now, important to be able to do is if you're given an equation of a transformation but you don't have a basic function to look at, you should also be able to perform the transformation. And in these cases you would be given a graph. And so to look at this, let's talk about like number 57. I really wanted to leave the odd problems for you, but this one I think involves a little bit more that I need to talk about. Let's look at part B with this. It says y is equal to the opposite of f of x minus 1. Well, the order of the way we perform these operations is going to be very important. The opposite of f of x is taking the opposite of y's, but the opposite of y's means to reflect across the x-axis and then shift down 1. You know what? We just did that, didn't we? But that's okay. It has a basic function that we don't really recognize. So whenever I do that, I'm going to shift -2, 0 to reflect across the y. Means I'm going to take the opposite of the y value, and then I'm going to move it down 1. So subtract 1 from the y. So the order of these things is very important. So -2, 0 to take the opposite of y stays at 0, but then I can shift it down 1 to be at -2, -1. -1, 2, I reflect it across the x, so that would become -1, -2, but I'm going to shift it down 1 to become -1, -3. 0, 0 reflected would still stay at 0, 0, but shifting it down would become 0, -1. 1, -2 reflected would become 1, 2, but now I shift it down to become 1, 1. 2, 0 reflected stays at 2, 0, but shifting it down 1 becomes 2, -1. So now my transformed graph will look like this. Okay, so it does a mirror image across the x-axis and then moves down by 1 unit. Now part C, I'm not going to work for you, but I just want you to be able to recognize this. This has a horizontal and vertical stretching involved. 2 on the outside means that you're going to multiply the y values by 2. 1/2 x, remember that if the value that you're multiplying by is less than 1, it actually does a horizontal stretch. And you really have to divide the x value by that, but to divide by 1/2 is the same thing as multiplying by 2. So you're going to multiply the x and the y values here by 2 to get the new graph. Okay. Now, this problem says, let the domain of f of x be -1 to 2, and the range be from 0 to 3. Find the domain and range of each of the following. So we're just going to see how these changes affect the domain and the range. For instance, number 68 says f of x, our new function is 2 times f of x minus 1. Well, what does the 2 on the outside do? It multiplies the y values by 2. What about the inside change? It shifts the x right by 1. So we've got to perform those changes to the domain and range. Well, shifting right by 1 affects the domain. So from -1 to 2, if we shift those values right by 1, that's going to be from 0 to 3. What about the range? From 0 to 3, but now we're multiplying by 2, so that would be from 0 to 6. So this is our new domain and range of the transformation. Okay, let's do one more of these, like number 72. It's -2 times f of -x. Got a lot of things going on here. We have a reflection across what the outside is the x-axis. We also have a stretch of 2. And then we have a negative on the inside is going to be reflection across the y-axis. So think about the order in which we would have to do these. We need to reflect across the x-axis first, stretch by a factor of 2, and then reflect across the y-axis. So if we're going from -1 to 2, how will our values of x be affected? Well, they're only going to be affected because of this reflection across the y-axis. So to reflect across the y-axis, we're going to take the opposite of the x. So the opposite would be from -2 to +1. Now our y values are going to be affected in 2 ways. We're going to have to take their opposites and then stretch by a factor of 2. Well, the opposite would take us to negative 3, 0, and then by a factor of 2 would be from negative 6 to 0. So that would be the domain and the range of that transformation. Now, I just picked a couple problems from my math lab because really what we've seen by hand or from the book is going to be similar to what you're going to expect to do online. This is to graph using the transformations. Opposite of 4 times the absolute value of x plus 3. The grid shows the absolute value of x in blue, and we've got to choose which one shows the opposite of 4 times the absolute value of x plus 3. Well, that opposite of 4 is doing a reflection across the x-axis. Then we're stretching by a factor of 4. And then we're moving up 3 units. Okay? So originally we're starting like this. Think of that V-shaped graph, the basic function. To reflect it, it's going to take it down like this. Stretch it's going to make it skinnier, right? And then we're shifting it up 3 units. So we need to look something like this that is shifted up 3 units, and that looks like part B. Now you can enlarge, click on the magnifying glass, and make sure that those values have actually indeed stretched by a factor of 4. So on the main graph we would have what? 0, 0, 1, 1, 2, 2, and so on. Just kind of talk us through here. To reflect across the x-axis, we move that point 1, 1 to what? 1, negative 1. But then stretched by a factor of 4 would be 1, negative 4. And then up 3 would be 1, negative 1. So in the final graph, we're looking at 1, negative 1. Okay, and this is actually counting by a scale of 2. So 1, negative 1 would be right here. Okay. Now, the last one here is to state the intervals over which the function is increasing. And so to do that, you're going to have to realize what shape your graph looks like. Negative 2/3, this is going to be a reflection across the y-axis, shrinking by a factor of 2/3, shifting right 2 and up 5. So we have a reflection across the x-axis, shrink by a factor of 2/3, right 2, and up 5. So the x-axis changes have to be done first, and then the y. So just to kind of think about this, really a problem that we just did on the last slide, if we want to reflect it across the x, it's going to make it go down, right, like that. To do a shrink by a factor of 2/3, it's going to make it wider, right? I'm not drawing this to scale, but just to kind of get your idea here. And then we're going to move it right by 2 and up by 5. So this point 0, 0 is really the key point. 0, 0 is going to go right by 2 and up 5 to the point 2, 5. So our shape is going to look like this. So increasing and decreasing, remember that is your intervals of x. So where is it increasing? Well, it's increasing as we move from left to right on this piece, right, because that piece is going up. So it's increasing from, what are those x values? From negative infinity to the value of 2. Where is it decreasing? From 2. Oops, didn't mean to do that. Sorry about that. 2 to infinity is where it is decreasing. So that's really just a review of the concepts that we talked about a while ago. Okay, so if you have any questions, please don't hesitate to contact me. Thank you.